Welcome back to Robbie's Office Hours. We have the unit circle on deck for today, which is not really people's favorite thing. Okay, unit circle means trigonometry. Trigonometry is typically not everybody's favorite topic, even though it is incredibly important in so many different disciplines. So let's try and demystify the unit circle a little bit today. Okay, so the idea with the unit circle is I've got my circle. Okay. This circle has the following equation. It's the unit circle, and it's centered at the origin. So it has the equation given as x squared plus y squared is equal to 1. Okay. Remember that a circle centered at the origin looks like x squared plus y squared equals radius squared. So the unit is referring to the radius here. So I can label some points here. This is 1, 0. This point is 0, 1. This point is -1, 0. This point is 0, -1. Okay? Now this video will give you an introduction to the unit circle. I'm not going to do a whole synopsis of what the unit circle is. I'm only going to focus on the first quadrant. Okay? So the angles that we need to know. Okay? The angles in radians. I'm not going to do degrees, but in radians. Okay? The angles are going to be 0. I need to know pi over 6. Okay? I need to know pi over 4, pi over 3, and pi over 2. Okay? That's what they are in radians. So what are they in degrees? Well, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? So really what I'm doing is I'm saying I've got 30 degrees, 45 degrees, 60 degrees, 90 degrees, and 0 degrees. Okay? So this would be something like theta is equal to pi over 6. This one is theta equals pi over 4. This one is theta equals pi over 3. The vertical one straight up the y-axis is pi over 2. And the horizontal one out here is theta equals 0. Okay? So we're only going to focus on those particular angles. Okay? Now for those angles, I have coordinates of these points on the unit circle. Well, I already know these ones. I know that this one is 0, 1, and I know this one is 1, 0. Okay? Now for the unit circle, what we're going to notice is what? Well, if I just take a random point here and I kind of drop this down, then this is the x-coordinate. That's the x-coordinate. And this thing here, so if I kind of drop this over, that's the y-coordinate. Okay, so whatever the coordinates of that will be, that's x and that's y. Well, if I let this be the angle theta that I'm talking about, okay, measured positively from theta equals 0 counterclockwise until I get up to here. So if that's theta, then I'm really looking at the triangle that looks like what? I have an x-coordinate here, I'll call that x. This y-coordinate, I'll call y here. This is theta, and that's equal to 1. And so what I notice is that x is equal to cosine of theta, and y is equal to sine of theta. Okay? That's why sometimes people will refer to, oh, the x is the cosine and y is the sine. It's because of this. Okay? It's because of the corresponding triangle associated to that. So the question we want to understand is what is cosine of 0, cosine of pi 6, pi 4s, pi 3rds, pi halves, and what is the sine? Well, what I know here is since cosine is the x-coordinate and sine is the y-coordinate, and this is the point corresponding to theta equals 0, I can say, well, let's make a table. Here's theta, okay, and here's cosine of theta, and here's sine of theta. Okay? So if theta is equal to 0, then cosine being the x-coordinate tells me cosine of 0 is equal to 1. Okay, so I'm going to say cosine of 0 equals 1, and therefore the sine of 0 is equal to 0. That's the y-coordinate. Okay? Now, I'm also going to have theta is equal to pi over 6, pi over 4, pi over 3, and pi over 2. Okay? I'm going to have those. And at pi over 2, I know what they are, because cosine of is the x-coordinate, so that's going to be 0. So cosine of pi over 2 is 0, whereas the sine of pi over 2 is equal to 1. Okay, so that's kind of the extremes. And this one, for theta is equal to 0, cosine is maxed out, sine is minimized. Whereas in this one, cosine is maxed out, or is minimized at 0, and sine is maximized at 1. Okay? Simply in terms of what do I mean by max and min, I mean in terms of their length. Okay? The largest the x-coordinate can be is a 1. The smallest the x-coordinate can be in length is 0. I mean, you could argue, I could get out to -1. We'll get there when we get to the other side of it, but for this quadrant, I'm only going from 0 to 1. Okay? So now what do I have for these ones? Well, there are 3 numbers that you need to remember. The 3 numbers are the square root of 3 over 2, 1 over the square root of 2, and 1/2. Okay? You need to remember those 3 numbers. Now, sometimes people write 1 over the square root of 2 as the square root of 2 over 2, and that's fine. They rationalize the denominator. That's fine. Fun fact, square roots are allowed to exist in the denominator. Some people argue against this. They say that the square root's not allowed to exist in the denominator. I disagree. QED, it exists. I wrote it on the board. It's right there. It's allowed to be there. Get over it. Okay? So the square root of 3 over 2, 1 over the square root of 2, and 1/2. The biggest thing that you need to understand in all of this is that the square root of 3 over 2 is bigger than 1/2. Okay? You need to understand that. The square root of 3 over 2 is bigger than 1/2. So that's the biggest thing to remember. That's a bigger number than 1/2. Why is that important? Okay? That's important because if I look at this particular spot and I say, what are its coordinates? Again, drop this down. The x-coordinate is this distance. The y-coordinate is this distance. Well, I would ask you, does the y look bigger or smaller than x? Well, the x looks bigger. Okay? Which one of these numbers is bigger? Square root of 3 over 2 or 1/2? Square root of 3 over 2 is bigger, which means that the x-coordinate, i.e. cosine, is going to be square root of 3 over 2. So for pi 6, I get cosine of pi over 6 is equal to the square root of 3 over 2, and the sine of pi over 6 is equal to the smaller of those 2 numbers. Okay? So I want you to kind of think of like square root of 3 over 2 and 1/2 as being 2 numbers that are paired together. Okay? Now at pi over 4, well, that's 45 degrees, which means the x-coordinate and the y-coordinate are equal to each other. Well, if I come up to this equation and I say that x equals y, then I get what? I get 2x squared equals 1, and that tells me x squared is 1 over 2. And if I take the square root, I get that x is equal to 1 over the square root of 2. Okay? So that means that if x and y are equal, cosine of pi over 4 is equal to 1 over the square root of 2, and so is the sine of pi over 4. Okay? And now here's the beautiful thing, and the beautiful symmetry, is that if I come up to theta is equal to pi thirds and I drop this one down, I notice that my x-coordinate is not as large as my y-coordinate, but so much so that all I have to do is take the cosine and sine for pi over 6 and switch them for pi over 3. So this will be cosine of pi thirds is equal to 1/2, the smaller of the 2, and sine of pi thirds is equal to the square root of 3 over 2. So there you have it. You have the first quadrant of the unit circle demystified. Okay? Now, speaking personally, I only memorized the first quadrant and a couple of tricks, which I'll explain in another video, in terms of symmetries and how I can kind of exploit that with some of the geometry around to be able to work my way around the rest of the unit circle and remember everything. Okay? But if you understand the first quadrant, that's going to get you 90% the way there. Okay? So if you like the video, smash that like button, comment down below, ask me questions about all this material. After all, this is my office hours.